Hey guys, so for my first video of my channel, I'm going to be going over a BOD question, which is the biochemical oxygen demand. And it should be a very quick question. It shouldn't take any more than 5 minutes. So let's get started. The concentration of BOD in a river just downstream of a wastewater treatment plant is 75 milligrams per liter. BOD is removed through a first order reaction at a rate constant of 0.5 over days. Given that the velocity of the river is 15 kilometers per day, what is the BOD concentration 50 kilometers downstream? So if we write out what we have right now, our givens, we have our initial concentration, 75 milligrams per liter. We have that it is a first order reaction. We have a rate constant of 0.5 over days. We have the velocity of the river is 15 kilometers per day. And our question here is, what is the concentration 50 kilometers downstream? So, since we know that it is a first order reaction, we can assume we're allowed to use our first order reaction equation, which is our concentration at 50 is equal to our initial concentration multiplied by e to the power of negative rate constant multiplied by time. So if we look at this here, we have our initial rate, we have our initial concentration, we have our rate constant, and we have our time. We'll just have to work a little bit for it. So if we solve for time over here, time, which is also our t value, we will get this. We have our 50 kilometers, which is the distance, and we have the velocity of the stream. And using distance and velocity, we can get a time. So our time t, I calculated to be 3.33 days. Now, notice how our values here is in days, and our rate constant value is in days. Now, if our rate constant was in 0.5 per second, you would have to then change over our time value to seconds. You can't just multiply the values together. It just doesn't work like that. You'd have to make sure that they match up. All right, so from here on out, it is basically a plug and chug. So 50 equals to our initial concentration of 75 milligrams per liter, our E value, to the negative rate constant, which is 0.5 per day, multiplied by our time, 3.33 days, all multiplied together. Now notice how our time values cancel out, which will just give us our concentration value at 50. So our concentration at 50 kilometers downstream, I calculated out to be 14.19 milligrams per liters. And that is our final answer for this short question on BOD concentrations. Thanks for watching, guys. I'm going to try to keep up the content at least once per week. I am an engineering student myself, so I'm going to try to find the time to work at these. And you can be expecting more quality questions real soon.